Let us start. Let's start the session. Hello. Good afternoon, everybody. Good afternoon, everybody. Let us start the Super 20 series of steel. Let's start the Super 20 series of design of steel structures, in which I would be discussing 20 good questions that is very much important for your GATE exam as well. So, let's start our discussion. Shall we start? Okay, let's start then. Let's start our discussion then. Let's start with a simple question, then I will proceed further again. Let's start with this question. I am giving you 2 minutes time, please solve it. Then I will also start, okay. So, we have to find out the plastic section modulus here in centimeter cube. Please solve this question. Giving you 2 minutes time. Let's start solving this question. Let's solve this question, please. Please attempt it. Very interesting question. This kind of questions are asked many times in your exam. So, we have to find out the ZP, that is the plastic section modulus for this section. Okay, I am just taking the figure here. All dimensions are in mm and you have to report your answer in centimeter cube. So, please start doing it. We already know what is ZP. For ZP, we work on equal area axis. Okay, all dimension are in mm here. For ZP, we work on equal area axis. The equal area axis for this section is at 100 mm. This is my equal area axis. This is at 100 mm. ZP, I already know what is ZP. A by 2 into y1 bar plus y2 bar. Y1 bar is the CG of the area from the equal area axis. This is my y1 bar. Find out the combined y1 bar. Y1 bar and y2 bar is same because this is a doubly symmetric section. I have given you much of the hint. Find out y1 bar, y2 bar, then I will proceed further again. Okay. Please do it, make it fast. Very simple question. I want answers from you, then I will proceed. Okay. Waiting for 2 minutes. Do it fast, please. Start the solution now. See, y1 bar is equal to what? Y1 bar is simply what? 140 into 9 into CG of this area. CG of this area will be how much? 100 minus 4.5, okay, because 9 mm is the thickness of this section, plus 100 minus 9 into 6.1, okay, into 100 minus 9 by 2. That's it. Divided by 140 into 9 plus 100 minus 9 into 6.1. That's it. This is my A by 2. So, y1 bar, how much you are getting here? Tell me fast. What is the value of y1 bar you got here? Please tell me. PYQ we have not planned yet. First we are doing fresh questions. Okay. First we are doing fresh questions. PYQ discussion we have done last year, so you can see those videos on YouTube only. Okay. .21 mm. This is equal to y2 bar also, and A by 2 is this quantity only. 1815.1 mm square. ZP is equal to what? 1815.1 into 2 into 8.21. This will come out in mm cube. Convert it into centimeter cube. 10 to the power minus 3, answer will come out in centimeter cube. So 291.18 centimeter cube. This is my ZP here. That is the plastic suction modulus. What we have to find out? The plastic suction modulus about the weaker axis. Okay, about the weaker axis they are saying. Sorry. They have asked us about the weaker axis, not about the stronger axis. Sorry. We have to find the ZP about the weaker axis. This is not the correct solution then. Wait. We have to find out the ZP about this axis. Okay. Do it again, please. We have to find out about this axis. I have did it incorrectly. This is also very easy. ZP will come out to be what? Take half area and multiply. Take first the area of these flanges. So A by 2 into y1 bar plus y2 bar. Do it fast. So first this flange you take 140 into 9 divided by 2 into 70 by 2, that is 35 plus 35. We have two flanges here, so into 2 plus, this is far more easier than this web, 100, 200 minus 18, that is 182. About the weaker axis they have said us, into 6.1 divided by 2 into 6.1 by 4 plus 6.1 by 4. This is my ZP. Multiplied by 10 to the power minus 3, answer will come out in centimeter. We have to find it by about weaker axis. I have not seen this. This is about the weaker axis. Okay. Please do it, make it fast. What answer you are getting here? Answer is 89.9. No. Answer is 89.9, my dear friend. So it was asked about the weaker axis. This is my weaker axis. This is my weaker axis. Okay, about the weaker axis it was asked. So first I found out the ZP of both the flanges. Then I found out the ZP of this web. 182 into 6.1. A by 2 into y1 bar is 6.1 by 4, 6.1 by 4. Please see, are you getting this answer or not? Yeah, correct. 89.9 centimeter. Very interesting question. Here, the ZP was asked about the weaker axis. Okay, let's see the next question. Find out the length of hinge here. Do this one now. Very simple question. Please try to solve this out. If you will know the formula, then only you will find it out the answer. Rounded off to nearest integer. So give your answer in integer here. Do it fast. Timing's running out. Make it fast, please. Waiting for answers. First find out the shape factor. A simply supported beam having a span of 10 meters. So, span was 10 meter. Very simple question if you know the formula. Of a UDL value was given to me, that is not required. Length of the plastic hinge if the beam is of circular section. See, shape factor of circular section is how much? 16 by 3 pi. That is 1.7. If you don't know this shape factor, then you won't be able to do this. And length of the plastic hinge, x is the length of the plastic hinge, is equal to L into square root of 1 minus 1 by SF, and length is 10 meters here. So, 10 into 10 to the power 3 in mm, square root of 1 minus 1 by 1.7. Answer in mm is how much? 6416.88 mm. That is, nearest integer is 6417 mm. Okay. Nearest integer is 6417. So, 6417 was the correct answer. If you are giving me 6417 as the answer, then it is very, very correct. Nobody is attempting it, I don't know why. Am I clear? Very simple question. Okay. Let us see the next question on plastic analysis. Attempt this question, please. We have to find out the MP of the section in tons meter. Please do it. Case of continuous beam. You will get your answer in integer. Please attempt it. I am waiting for answer. Very simple question again. Do it fast. Do it fast, please. Very good. Let's see. You have to find answer in tons per meter cube. Sorry, tons meter MP. Let's try to solve this question now. Let us try to solve this question now. Let's try to solve this question. Okay. Not at all a tough question, and this is a question of continuous beam in which we will have to consider all the segments separately. First, I will consider failure of AB span. Okay, let's see. Failure of span AB. Just apply the kinematic method and go on. So, here it is AB. Hinge will form. This is 6 tons. Theta, theta. Theta again. Here we will have MP. MP, MP. That's it. Let's see. Let's see. So, first find out MP for this one. MP for this one is how much? MP is equal to how much? Tell me fast. That is 60. This is 1.5 meter, 1.5 meter. 60 into 1.5 theta is equal to 3 MP theta. So, it is coming out to be how much? MP is coming out to be how much? Tell me fast. That is 3 tons per meter. Now, consider failure of span BC again. On the similar line, failure of span BC we will consider. And MP will be largest of all the values. Okay. Very beautiful question, can be asked in GATE as well. This was AB. If this is theta, this is theta again. This is theta, theta. 8 tons. This is 2 meters each. Now, 8 into 2 theta is equal to here MP, 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 and here also MP. So, it is 4 MP theta. MP is equal to how much? MP is how much you are getting? Tell me fast, please. All the beams have same MP. Okay. Tell me what you are getting here. How much you are getting? MP is how much? MP is equal to 4 tons meter here. Lastly, failure of CD. Only one hinge is required for its failure. Theta 3 meters. CD load is 3 tons. MP, so 3T into 3 theta is equal to MP theta. So MP is equal to 9 ton meter. So MP is maximum of all the values. Maximum of 3, 4 and 9. Answer is 9 tons meter. Very simple question. Good afternoon, Kajal ji. Start doing the questions, please. Answer is 9 here. So if you have given me 9 as the answer, then it is correct. Please give your answers in the comment section. Without units, just give your answer in the comment section. Our software will automatically catch it. Okay, and you will see your names on the polls as well. Anyways, let's see the next question. Next question is of welding. More than one answer can be correct. Please solve this one as well. Tell me fast answer of this one. Tell me fast, please. See. So, what is the answer of this question? We have to find out the correct statement regarding welding. So, welded connections are more suitable for bolted connection for impact as well as vibration. This is correct. This is vibration. Okay. Vibration. For vibration, it is more suitable. N will also be there. Typing error. Anyways. Okay. Welding leads to more rapid construction, saves time in the project, that is correct. Welding is much easier to do. You don't have to punch holes and etc. So, it saves a lot of time. Welding leads to rigid connection as compared to bolted connection. Welding requires skilled manpower and special equipment. So, A, B, C is the correct answer here. If you are giving me A, B, C as the answer, it is correct. So, Mr. Prabhat have given me and Mr. Tree Palagimin, whatever your name is, have given me the correct answer. Let us see the next question on find out the answer of this question. Do this one please, make it fast. Do this one please. One answer is correct here. Very simple question again. Solve it fast please. We don't have all day for this. 3 plastic hinges are required to be formed here. Okay. We have to find out the collapse load in terms of MP. That's it. Let's do this. Okay. Let's do this. So, this is my collapse mechanism here. One hinge at C and one hinge at D, A, B, C. All will be theta theta, but MP will be different here. Here MP is 2 MP. Here it is MP only, lowest of the two we will take, and here it is again MP. Apply principle of virtual work. So, PL theta is equal to 5 MP theta. So P is equal to 5 MP by L is the correct answer. So if you are giving me 5 MP by L is the answer, then it is very correct. That is C, not BD. C was the correct answer. I don't know why you are giving me the wrong answers. Very simple question again. Few have given me, Prabhat and again Mr. Tree, Mangalam, whoever you are, have given me the correct answer. Rest of you, please attempt it. Okay. Give it a good try, please. Okay. Give it a good try. Give it a good try. Very good questions. Are you liking the questions? Let's see answer of this one, whether you will be able to do it or not. Simple questions again, please solve it. Clear? As per IS code, an unequal angle section used as a compression member would primarily undergo which type of buckling? So for unequal angle section, we generally have flexural torsional buckling, you should know. For angle section with single leg connected, we what kind of buckling we are? Flexural torsional buckling, not torsional buckling, it's flexural torsional buckling. B was the correct answer, my dear friend. B was the answer, nobody have given me. Very simple questions again. Let's see the next question. Let's do one interesting question on block shear failure. Try to attempt this one here. Interesting question, please try to attempt it. Try to do this question. Waiting for answers, it will take time. No worries, take your time, please. Take your time and find out the block shear failure here. Block shear failure strength. Very important question for GATE. Okay. Try to do it, friends. Try to do it. Okay. Okay. Let's do it. Are you able to do it? We have two gusset plates here. So find out the block shear strength of one and multiply it by 2. That's it. Let's do it. Very easy question, but interesting one again. Every area was given to me. So I will use all the areas and then proceed with the solution. This is thickness of flange, okay. This is thickness of flange. For one flange, we will find out the TDB and we will multiply it by 2. That's it. So see here, first find out A and B, AG, AVG. AVG is equal to how much? I only need the thickness of this. Okay. Thickness of this plate is how much? Evaluate the use grade of steel this, and we have to evaluate the block shear strength of this flange. So flange thickness I will take, that is 10.2 mm. So AVG is equal to how much? This total length from here to here is how much? Please calculate. 16 to 4. 285. 285 into 10.2. Okay. 2907 mm square. Okay. AVN also you calculate, that is 285 minus 4 into 4.5. Dia of bolt hole will be how much? If D is 20 mm, D naught will be 22 mm. So take dia of bolt hole as 22 mm. So 4 bolt and last one half. So 4.5 into 22 into 10.2. 1897.2 mm square. ATG and ATN also you calculate. ATG is 35 into 10.2. 357 mm square. ATN is equal to how much? 35 minus 10.2 by 2. Sorry, 35 minus 22 by 2 into 10.2. Now, TDB is equal to minimum of shear yielding tension rupture Fy by root 3 into 1.1 into AVG plus 0.9 Fu by 1.25 into ATN. 0.9 Fu by root 3 shear rupture 1.25 into AVN plus Fy by 1.1 into AT. Fit everything here. 250 by root 3, 1.1 into AVG, 2907 plus 0.9 Fu by 1.25 into ATN, that is 244.8. Just fit all the values and multiply it by 10 to the power minus 3. You will get the answer in okay. AVN 1897.2 plus Fy, that is 250, ATG is 357. Minimum of the two values you will take. Tell me what values you are getting in both the cases. Please solve it with me. Solve it, please. $453.71. Then you will multiply it by 2 because there are two gusset plates there. Okay. These kind of questions you can very much expect in your exam. Now, therefore, TDB is equal to twice of 404.48. That is 808.97 is the correct answer. Like this, you find out the block shear strength. Why we are multiplying by 2? Because there were two gusset plates. Okay. So, answer is D. So, if you are giving me D as the answer, it is very, very correct. Okay. D is the correct answer. Kajal and Mr. Tripal have given me the correct answer. Okay. Very good. These kind of questions you can very much expect in your exam as well. I am proceeding further again. Let's proceed further. Tell me the answer of this one. Find out the incorrect statement here. More than one options can be correct here. Tell me answer of this one as well. Batten and lacing, batten column and lace column. Tell me answer of this one. That is what here we have to find out the incorrect statement, my dear friends. Patterns are designed to resist both shear force and flexural moment. That is correct. Lacings are not designed for axial force. Lacing and battens are never designed for axial force. They carry only transfer force. Effective strength ratio for lace column is increased by 5%. For batten column, it is increased by 10%. Effective strength ratio for batten column is taken 10%. More than that, that is also correct. So B is the incorrect statement. So if you are giving me B as the answer, that is very correct. Only one statement was incorrect. Okay. B is the correct answer. Kajal ji have given me the correct answer. Very good, Kajal Sahu ji. Let's proceed further now. Let's see one question on portal frames. More than one answer can be correct here. Please try to solve this one. Try to solve this one. Very interesting question again. A lengthy one. So take your time, solve it properly. Okay. Do it fast. Solve it, please. If it is done, let me know. This question, very interesting question. More than one option can be correct. Now, first find out number of independent mechanisms for the given frame. Number of independent mechanism is how many? See, one beam mechanism and one sway mechanism. That's it. 3 reactions here, 3 reactions here. From formula also we can do. Redundancy is 3, 6 minus 3. Number of location of plastic hinges 1, 2, 3, 4, 5. N is equal to H minus R. 5 minus 3, that is 2. So, number of independent mechanisms here is 2. So, first one is not correct. First one is not correct. Collapse load obtained from beam mechanism. For beam mechanism, we will consider the failure of BC span. So, for beam mechanism, very simple. Consider the failure of BC span. 2 MP, and here it is 2 MP and there it is 1.5 MP. Okay, 3 meter and 4 meters. If this is theta, this is phi, theta phi, 1.5 MP, 2 MP, and here also 2 MP. Okay, this would be my mechanism, plastic mechanism here. First, write down the compatibility equation, then I will proceed further, and W is the load here. So, 3 theta is equal to 4 phi. Now, W into 3 theta is equal to 2 MP theta, 2 MP theta, 4 MP theta plus 3.5 MP phi. Fit phi here, 3 by 4 theta. So, W into 3 theta is equal to 4 MP theta plus 3.5 MP 3 by 4 theta. What is W you are getting? Tell me fast. W is equal to how much you are getting? Tell me fast, please. Write down the answer. Tell me fast. W you are getting how much? .21 MP. For beam mechanism, answer is how much? 2.21 MP. And what answer was given to us? 4.21. This is also wrong. Collapse load obtained by sway mechanism is how much? For sway mechanism, take the collapse load. This is my sway mechanism now. Now, if this is delta or this is theta, that is phi, take theta phi only. Interesting question. 6 and 4, 2 MP, 1.5 MP. Okay. This is W by 2, 6 and 4 meters. So 6 theta is equal to 4 phi, equation number 1. Here it is 2 MP. Theta 2 MP, and here it is 1.5 MP. So 4 MP theta, W by 2 into 6 theta is equal to 4 MP theta plus 3 MP phi. Substitute this phi here, find out the value of collapse load. Tell me fast what answer you got. I got the answer as 2.83 MP. This is the collapse load for sway mechanism. This is correct, C is correct here, okay. Now the combined mechanism also I will take. So sway mechanism I have taken. From one question the whole portal frame is covered, okay. Okay. Now let's see the combined mechanism. In the case of combined mechanism, if sway is on the right side, there will be no forward hinge at B. So combined mechanism will look like this. This is theta. Then this will also be theta. W, W by 2. This is theta again. This is phi. This is phi. And here this one is delta. This one will also be delta. Okay. That seems okay now. Okay, let's solve this now. First, write down the compatibility equation. This is 4 meter. Sorry, this is 6 meter. 3 meter, 4 meter. 3 meter, 4 meter. And this one is 4 meter again. First 6 theta is equal to 4 delta and 3 theta is equal to 4 phi. This is 2 MP. Here there is no hinge, 2 MP, 2 MP. Here we have 1.5 MP this side and 1.5 MP this side. And lastly 1.5. So now W by 2, 6 theta plus W into 3 theta is equal to 2 MP theta, 2 MP theta. So 4 MP theta plus 3.5 MP phi plus 3 MP delta. This only, right? Substitute everything here, you will get the answer. So tell me what answer you are getting here. W, that is 6 W theta is equal to 4 MP theta plus 3.5 MP. Phi is 3 by 4 theta plus 3 MP into 6 by 4 theta. So W you will get from here. How much W you are getting? 1.854 MP. Please see. 1.854 MP. Please verify once. So this is the minimum of all, and this is my collapse load also, and this is only my collapse load. That is the minimum of all for the combined mechanism. So combined mechanism is governing here. So collapse load is this one only. So C and D were the correct answer. Very good question on portal frame. From one question we have understood everything here. Nobody have given me the answer, but question was very simple. These kind of question you can very much expect in your exam. Okay. Tell me fast answer of this question. More than one option can be correct here. Take your time, tell me the answer please. Make it fast please. Do it fast. Tell me the answer. Do it fast. Following is not correct, they are asking. Okay. So local buckling can be prevented by only limiting the width to thickness ratio of plate elements. Local buckling can be prevented. It is written can't. This is wrong. It can be prevented. It depends on width to thickness ratio only. Maximum stance ratio for lacing bar should not be more than 145. This is correct. Hot rolled hollow section fall under buckling class C. No, they fall under buckling class B. Battened column is preferred for eccentrically loaded column. No, there we prefer laced column. So A, C, D are incorrect statements. A, C, D. If you are giving me A, C, D as the answer, very correct. These kind of questions you can very much expect in your exam. Rishu Kumar have given me the correct answer. Very good. Let's proceed. Tell me the answer of this question. Make it fast, please. Do it fast. Tell me the answer of this one as well. Very simple question. Tell me the answer here. Make it fast, my dear friends. Waiting for it. Do it fast. Two loads are given, 4 bolts are there, so 2P should be equal to 4 VDP, that's it. Tell me the answer. Determine the maximum load P that can be applied. Shear strength of both all bolts is this one. So P is equal to 2 times VDP, that is 2 into 90, 180 kilonewton. That's it. Answer is P. Very simple question. Question can't be more simple than this. Okay, B was the correct answer. Kajal ji have given me the correct answer. Very good. Let's proceed further. Find out the force here. Find out the answer of this question. Do it fast, please. Make it fast. Then find out the work done under the UDL. For UDL, how to find out the work done? For example, you have a UDL like this. Virtual work done by UDL is nothing but area under the deflected shape. If this is theta and this is L, so half into L into L theta. So this will be the work done by the UDL in that case. That is UDL into area under the UDL, area under the deflected shape. This is the work done by UDL, and take the work done by the point load separately. Find out the virtual external virtual work, equate it with the energy stored in the hinges. That's it. Very good. So I am getting answer of this question as well. Force in the single lacing is what? V by 2 sine theta. Sorry, V by 2 cosec theta, V by 2 sine theta. V is 2.5% of the factored axial load. 2.5% of the factored axial load is 1200 is equal to how much? That is 30 kilonewton. Less theta is 45 degrees, so V by V is 30 divided by 2 sine 45 degrees. How much you are getting the answer? Tell me fast. That is 21.21 kilonewton. I have got one answer as well. Very correct. Very simple question. Okay. Let's proceed towards the next one. Do this question of beam. Do this as well. Make it fast. Okay, Rishu, we will solve one of these questions in Mahabhyas. I will try to include it. Let us see the answer of this as well. See, for low shear case, P should be equal to 0.6 VD. Just find out VD here. VD is Fy by root 3, 1.1 into H into TW. Fy is 250 by root 3, 1.1. Very simple question. Overall depth is how much? 100 ISMC, and thickness of web was given to me, that is 5.7. Multiplied by 10 raised to a minus 3, you will get your answer in kilonewton. So, how much you are getting? Tell me fast. 74.79 kilonewton. Now, P is equal to 0.6 into 74.79. Please verify. Answer is 44.87. So, for low shear case, lower integer you will take. If you take 45, then it will become high shear case. So, nearest integer will be 44 you will take, okay. 44 would be the correct answer, not 45, okay. Do not take 45 as the correct answer, take 44 as the correct answer, okay. Kajal ji, very interesting question, it's simple only. I have tried to include many type of questions here that will help you a lot. Solve this one as well. For purlins, you have to solve. Tell me the answer. Make it fast. Few more questions, then I will do. Do it fast. Do it fast. Maximum bending moment is WL square by 10. UDL is how much? W into L is 80 kilonewton. 80 kilonewton. So just substitute it here. So 80 into length is 8 by 10. That is 64 is the correct answer. For purlins, my maximum bending moment is WL square by 10. That you will have to remember. Very good, Kajalji. C was very correct answer. Very good. Let's proceed. One of the last or the last question for today's session. Please solve this as well. Very good question. Try to solve this. You have to find out the equivalent stress. Equivalent stress, okay, or the resultant stress, you can say. Find it. Do it fast. First find out the direct shear stress and then find out the bending stress. So here we have two lines of weld. You can see fillet welding was done. So size is 10 mm. TT is equal to Ks, that is 0.7 s, that is 7 mm. Throat thickness is 7 mm. Now Q, that is the direct shear stress, first find out. that is the factored load 150 upon twice of this area, 280 into 7. How much you are getting in MPa? Tell me the answer in MPa only. Yeah. So answer is 38.26 MPa. Fa is equal to m into y upon I. Moment is 150. 150 into 10 raised to power 3 into eccentricity is 80. Y is how much? 280 by 2 upon 2 into TT, 280 cube by 12. So how much you are getting Fe? That is axial stress. 65.6 MPa. Now equivalent stress is equal to how much? Fa plus 3q square square root. You should remember this formula. Many times in GATE question is asked from here. 65.6 plus 3 into direct shear stress, that is 38.26. Square root, square is the correct answer. Tell me fast. Answer is 93.24 MPa. Now we will continue with more questions in the Mahabhyas session in the evening today. At 6:30 we will meet again. So in this session I have discussed around 20 questions. In the Mahabhyas session again I will discuss few more questions.